Good day everyone, my name is Trisha Roja and our topic for today's video is redox reactions as applied to galvanic and electrolytic cells. I will be discussing the electrochemistry involved in some common batteries with Miss Mea Domasian. Miss Iris Adriano will apply the electrochemical principles to explain corrosion. Miss Sofia Diang will explain the electrode reactions during electrolysis, and Miss Abby Villagomez will describe the reactions in some commercial electrolytic process. So first, let's define electrochemistry. Electrochemistry is the branch of physical chemistry concerned with the relationship between electrical potential as a measurable and quantitative phenomenon and identifiable chemical change with either electrical potential as an outcome of particular chemical change. So let's also define a battery. A battery is a device that converts chemical energy contained within its active materials directly into electric energy by means of an electrochemical oxidation reduction, or simply called redox reaction. Battery has two types, the primary batteries and the secondary batteries. The primary batteries are those which whatever chemical reaction is taking place, it does take place, and the products are formed. It results in the generation of electric current, but once the reaction takes place and the products are warmed and the electricity has been produced, whatever is left behind, that is the product of the reaction. They cannot be reversed and the battery cannot be used again. You have to discard the battery. So the primary batteries are those which cannot be recharged. So on the other hand, secondary batteries are those which can be charged or which can be recharged. This will be discussed later by Miss Mea Domasian, but now let's only focus on primary batteries. So primary batteries will be batteries in your watch, the battery you have or you used in your remote controls, and the batteries that you have in your clocks. These are batteries that cannot be recharged. They are known as primary batteries. The first category is the primary batteries. We will be studying two types of batteries in the primary batteries. But let's first discuss the Leclanche cell or dry cell. We are all aware of this cell that small AAA batteries and AA batteries are called Leclanche cell. So as you can see, we made cross section of it. In the other section, we can see what's inside of the cell. And on the outside, what we see is a cylinder. And the cylinder or the cup is made up of zinc. That entire body is made up of zinc. This cup or the zinc container or the zinc cylinder acts as the anode. And do you see two sides of this battery? There is one flat and there is one which has a little knob on the top. It is actually only a cup, and that cup is of the cathode. And what is the cathode made up of? Cathode is made up of carbon rod and graphite rod, and the carbon rod forms a cup. If your pencil lead brushes against something, therefore, the zinc cup is only a protection of it. Actually, the rod that is attached. The actual electrode is a carbon electrode. Now, there is more important thing to know about the difference between electrolytic cell and electrochemical cell. So, in the electrolysis, the anode is the atom. It is the positive electrode, and the cathode is the negative electrode. The cathode is that electrode which always reduction takes place, and the anode is the electrode that always oxidation takes place. So in a battery, you still have cathode at which reduction takes place, and anode at which oxidation takes place. But the reaction here is the opposite, because the chemical reaction is taking place and it will result in the generation, and the electron were entering into the solution to the cathode, and the electron will be generated inside the cell and they will leave from the anode. But the reaction are still the same. That oxidation and reduction are still the same, yet the anode is the negative electrode and the cathode is the positive electrode of a battery. So the signs are different in electrochemical cell and electrolytic, but cathode and anode are still defining the same way. So the entire container is the anode, and the cylinder between is made up of carbon and is also called the cathode. The electrolyte that is there, if you rip this entire container open, you will notice the laser is a solid, a semi-solid kind of substance which acts as the electrolyte, and the mixtures of manganese dioxide and carbon black in an ammonium chloride paste. So that is what makes the electrolyte. Now, what are the reactions that takes place at the anode and cathode? So, in the anode, which has zinc, the zinc is participating electrode. So, what happens at the anode? The entire container loses 2 electrons and calls it into positive, and 2 electrons are released. Now, losing electrons is oxidation, so oxidation occurs, and these 2 electrons that are produced will move to external circuit and be the cause of electric current at the same time. So, what happens in the cathode? Manganese oxide that is present here in electrolyte, ammonium ions which is also present in electrolyte, they gain electrons, results in the formation of MnO and ammonia, and the oxidation store of manganese was +4 and it reduces to +C, so therefore manganese dioxide is getting reduced. So production occurs at the cathode and the oxidation occurs at the anode, and this ammonia that is generated in the reaction at the cathode. It forms a complex by combining with the zinc cap, and when the zinc at the anode reacted to give you zinc ions, the zinc ions enter the solution. These zinc ions will combine with the ammonia and result in the formation of complex. And this complex is the complex of zinc and ammonium ions. ZnNH3 to positive is the complex sign that is created the EMF of this. This is usually 1.5 volts of Leclanche cell. The second kind of batteries that we would like to understand is the mercury cell or button batteries. A little tablet kind of battery that we use in our weight machine and that are used in our watches are known as the mercury cell. And what do they have? We look at this tablet and we try to make a cross-section of it. You will notice again that it has color. And this color is an anode. On the top of it, you can see the anode cap. And if you rip it open, you will see the 2 layers with a separator in between 2 layers of components. The first layer forms the anode. On the top of the anode is the anode cap. Then in the middle, there is a separator. And below, there is the cathode. And since it is the mercury cell, zinc and mercury amalgam are present, and they form an angle zinc and mercury amalgam whenever you have a mixture of mercury with a metal that is known as the amalgam of the metal. So, zinc and mercury amalgam that forms the anode, and the paste of mercury oxide and carbon forms a cathode. Zinc amalgam plus mercury oxide will give you what you have in the product. Zinc oxide and mercury is a liquid. So this is the overall that takes place in the mercury cell or boton batteries. The EMF of mercury cell is 1.35 volts. So now, let's hear Ms. Mea Domasian to discuss the primary batteries.
Electrochemistry in fuel cells. Fuel cells are electrochemical cells that produces electrical work from oxidation of hydrogen. Now let's look at the oxidation and reduction found in a fuel cell. The oxidation of fuel cells is as follows. The diatomic hydrogen is oxidized and releases 2 plus ions and 2 electrons. Its reduction reaction. A diatomic oxygen molecule takes 2 electrons and takes 2 plus ions and then from the anode and then forming water in its liquid state. Now our redox reaction is found after adding up the oxidation and reduction reaction. The 2 plus ions are found in the 2, so we cancel them. Then we have our net redox. Our cell potential is 0.7 volts. It is positive. Now let's look at the layout of the fuel cell. A fuel cell is like any other electrical chemical cells that has an anode and a cathode. It has a conductor that carries electron from the anode to the cathode. This part here is the outside system that receives electricity in a form of current flow. Anode is negatively charged because it gives away electrons, and cathodes are positively charged because it receives the electrons. When the H2 molecules enters the system, it is oxidized. How does this happen? Well, the platinum catalyst, this part, acts to speed up the reaction from this to our product. Then the molecule enters the anode, it reacts with the platinum, reducing 2 molecules of H plus ions and 2 moles of electrons. Now these electrons travels through the conductor to the cathode. This part provides electricity to the outside source. When the electron travels all the way to the cathode, they react with the oxygen molecule, reducing it. Notice that there is a membrane in between the anode and the cathode. This membrane only allows H plus ions to flow from the anode to the cathode. It does not allow electrons to pass through this membrane. In order for the buildup of H plus ions not to occur in this side, the membrane acts as a bridge for these protons to pass to this side. This has a significant purpose because if the anode has a buildup of positive charge here and a line of positive charge here, that would mean that the electron will stop flowing. When the H plus ions reach the cathode, they react with the oxygen and the electrons and they form water. This water will need to be released so the cell will not stop functioning. The water will leave this system of pump. Just the same way the H2 molecules are allowed in the anode, the oxygen molecules are also allowed inside the cathode. When this oxygen enters the cathode, they react with the H plus ions and the electrons that flows into the cathode, forming water. This continuous process powers an outside source in this area. There are a few problems with fuel cells. First and foremost, the diatomic H2 gas molecules does not occur in nature. It takes a lot of energy and it is expensive to generate. The second issue is that the H2 molecule is flammable. Thus, it is difficult to store. Now let's move on to discussing lead storage battery. Lead storage battery is commonly used as a storage battery or a secondary battery. The material used for the lead acid storage battery cells are as follows: lead peroxide, sponge lead, and disulfuric acid. The positive plate of the lead storage battery is made of lead peroxide. The negative plate is made of pure lead in soft sponge condition. The disulfuric acid used for the lead battery has a ratio of water is to acid equals 3:1. The lead battery is made by dipping the plates in sulfuric acid, wherein a conductor or load is connected in between the plates. When the hydrogen plus ion reach the lead peroxide plate, they receive electrons from it and becomes hydrogen atom. They form lead oxide and water. This lead oxide reacts with the sulfuric acid and forms lead sulfate and water. The negative sulfate ion moves freely in the solution, and some will reach the pure lead plate, wherein they gives the extra electron and becomes radical sulfate. It will react with pure lead and will form lead sulfate. Since the positive hydrogen ion takes an electron from the lead peroxide plate and the negative sulfate ion gives electron to the pure lead plates, there would be an inequality of electrons between these two plates. Hence, there would be a flow of current to a conductor between the two plates to balance the inequality of electrons. The formed hydrogen atoms react with the lead sulfate and form lead and sulfuric acid. The formed radical sulfate reacts with lead sulfate of an anode and forms lead peroxide and sulfuric acid. By charging the lead storage battery cells, it becomes ready for discharging. The next topic will then be discussed by Iris.
The electrochemical theory of corrosion, or applying electrochemical principles to explain corrosion. The electrochemical theory was formulated by Whitney, and it was based on the Nernst theory. The overall mechanisms of the electrochemical theory can be divided into two parts: the anodic process, or the reactions which will take place at anode, and the cathode process, or the reactions which will take place at cathode. Let's first discuss these two reactions. Anode, or the anodic process. So this is where the oxidation process will take place. So from M, it will convert itself into an Mn plus and an N electron minus. So from zero oxidation state, it will convert itself into Mn plus and generate the same number of electrons. Next is the cathode process. So in the cathode process, there will be three reactions taking place. The first one is electroplating. So in electroplating, the metal cation which we have generated will consume electrons to transform itself or convert into metal. Next is the liberation of hydrogen. So the liberation of hydrogen usually takes place in acidic mediums. So this 2H plus will consume electrons to convert itself into H2 or transform itself into H2. The third one is absorption of oxygen. So in the absorption of oxygen, this usually takes place in alkaline or neutral mediums. So this water, oxygen, and electrons will react to form hydroxide molecules. According to electrochemical theory, corrosion of metals occurs due to the following changes when they are exposed to the environment. A large number of minute galvanic cells are formed, which acts as anodic and cathodic areas. At anode, the metal undergoes oxidation and electrons are liberated, which migrates towards cathodic region. Oxygen of the atmosphere undergoes reduction at cathodic area in the presence of moisture, forming hydroxyl ions at the cathode. So according to the electrochemical theory, the chemically non-uniform surfaces of metals behave like small electric cells in presence of water containing dissolved oxygen and carbon dioxide. So after those reactions, the anodic process and the cathode process, the second important part is this diagram. We find it difficult to draw this diagram, so let's simplify this.
So this is the metal surface we will have. And on this surface, there will be a thin film of water. So this is a thin film of water. Some part of this surface will act as anode and some part will act as cathode. So this is an ion surface wherein all the reactions will take place. So at anode, this Fe will oxidize to Fe2+, and these Fe2+ ions will come into the solution and it will leave 2 electrons on the surface. So these electrons will travel toward cathode, and at cathode, the water molecules will dissociate into H+ and OH-. H+ will react with 2 electrons and it will form H2. So right now we have a few 2+ ions and OH- ions. So these Fe2+ ions will travel toward cathode and these OH ions will travel toward anode. And afterwards it will form ferrous hydroxide. This is the first corrosion product that will form.
In the electrochemical theory, the formation of corrosion product is also a part of the cathodic process reaction. So when the hydroxide ions migrate towards anode and reacts with metal ions, it will form the corrosion product. So in the case of iron OH reacts with Fe2+ ions, it will form an insoluble hydrated ferric oxide known as the brown rust.
That is all for electrochemical theory of corrosion. Up next is Miss Dayan.
Now, I will be explaining the electrode reactions during electrolysis. But let us first define electrodes and electrolysis. Electrode is a conductor through which electricity enters or leaves an object substance or region. Electrodes are the means by which liquid and living organisms are included in the electrical circuits, while electrolysis is a process by which electric current is passed through a substance to effect a chemical change. Anode is a positive electrode which attracts anions, while cathode is a negative electrode which attracts cations. If it's hard for you to remember, just think of the words "don't panic," where panic means positive is anode, negative is cathode. Anything positively charged in a liquid is going to be attracted to the negative electrode, and the negatively charged is going to be attracted to the positive electrode. Because opposite electrical charges attract. In electrolysis, positively charged ions move to the negative electron. They receive electrons and are reduced. Each ion gains 1 electron and sodium metal is produced. While the negatively charged ion move to the positive electrode, they lose electrons and are oxidized, opposite to the cathode. The single chlorine atoms then pair up to form chlorine molecules, and chlorine gas is produced. In simpler terms, the reaction at the anode is oxidation, which means loss of electrons, and the reaction at the cathode is reduction, where it gains electrons.
Hi, this is Abigail Villagomez and I will describe some commercial electrolytic processes. These are the ones I'm going to describe. The production of aluminum and metal plating. The production of aluminum. Aluminum is the most abundant element on Earth. However, it is expensive because it requires high amount of electricity to be extracted. The aluminum ore is called bauxite. Bauxite is then purified to produce aluminum oxide, just like a white powder. Then, the aluminum is extracted from aluminum oxide. The setup will look like this. Then, the process of electrolysis will take place. Here is the overall reaction. At the negative cathode, where the aluminum forms, the aluminum ions from the molten aluminum oxide cryolite solution, they are reduced, which means they gain electrons. It will be presented into this half reaction. At the positive anode, where the oxygen react with carbon to make carbon dioxide, the oxygen ions are oxidized. This means they lose electrons. It will be presented into this half reaction. Next is electroplating or metal plating. In the process of electrolysis, many decorative objects like jewelry are produced to modify its surface for protection and corrosion. Electroplating is a process that adds a surface layer to a metal to another type of metal. Let's take copper metal as an example to be placed onto a second metal. The setup will look like this. The cell consists of a solution of copper sulfate and a strip of copper which acts as the anode. The metal is the cathode. Then, the anode is connected to the positive electrode of the battery while the metal is connected to the negative electrode. At the anode, when the circuit is closed, the copper metal is oxidized, which means they lose electrons, allowing copper ions to enter the solution. It will be presented into this half reaction. Meanwhile, at the cathode, copper ions from the solution are reduced to the copper metal, which means they gain electrons on the surface of the second metal, forming a layer of shining copper. It will be presented into this half reaction. The concentration of copper ions in the solution is effectively constant. This is because the electroplating process transfers metal from the anode to the cathode of the cell. Besides that, there are other metals plated onto objects such as gold, silver, platinum, and chromium. So that's all, and thank you.